All right, today's lesson 6, is called Distance and Change Between Two Rational Numbers. This is based on the same standard that we've been working on, which is apply properties of operations to add and subtract rational numbers, including real-world contexts. We're going to be able to answer the questions, how can I find the distance between two rational numbers, and how can I find the change between two rational numbers? The first question we have is, what is the distance between -4 and 5, and how could you use a number line to find the difference? So I'm going to plot these 2 points on the number line. First I'm going to do -4, and then I'm going to do 5. Now if I want to know the distance between those 2 points, I'm just going to count how many units there are in between the 2 points. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the distance between -4 and 5 is 9 units. Now I'm going to find the distance between 5 and -4. So I'm going to put my dot on 5, and then I'm going to put a dot on -4. I can see that this is exactly the same as what I did up above. It doesn't matter what order I place the numbers in. It's still going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 units between them. So the distance between -4 and 5 is the same as the distance between 5 and -4, which is 9 units. Okay, now we're going to look at the distance between -5 and -3. So I'm going to plot a point at -5. I'm going to plot another point at -3. The distance between -5 and -3 is 1, 2 units. Okay, if I want to find the distance between -3 and 5, I'll plot a point on -3, plot a point on -5, and same 2 points, just in a different order. The distance between them is the same, 2 units. Okay, now I'm going to find the distance between 7 and -1. So I'll plot a point at 7, plot another point at -1. Count the units in between. 1, 2, 3, 4, 5, 6, 7, 8. So the distance between 7 and -1 is 8 units. I bet you can guess what's going to happen in the next one. We're finding the difference between -1 and 7. Once again, same 2 points. Order doesn't matter. It's going to again be 8 units. Okay, now this asks in a little bit of a different way. Let me move this out of the way. There we go. The distance between a positive and a negative number is 8 units. What could the numbers be? Well, first we have to notice that one of them needs to be positive, the other number needs to be negative, and there has to be 8 units in between them. So there's actually a lot of different possibilities here. I'm going to show you a couple different ones. First of all, what if I started on a -2? Then I could count 1, 2, 3, 4, 5, 6, 7, 8, and the positive number would have to be 6. So one possibility is -2 and 6. Let's try another possibility. Let's see if we were to start, how about at -5 this time? And we're going to count 1, 2, 3, 4, 5, 6, 7, 8. This time we end up at 3. So the distance between -5 and 3 is also 8 units. Let's try another one. How about if I start at -10? Let's see what would happen. 1, 2, 3, 4, 5, 6, 7, 8. I end up at -2. Could I write that down as a choice? -10, -2. I hope you're thinking, no, you could not write those down as a choice. Any idea why? Hopefully you're seeing that we need a positive and a negative number. These are both negative, so that does not work as a choice. We can't pick a negative number that's so low that when we count 8 units, we're still in the negative zone. We have to get into the positive zone. So how about if I try, let me start on -8. Before I draw this, I want you to think to yourself whether or not this is going to work. If I go a distance of 8 units, am I going to end up on a positive number? Let's see. 1, 2, 3, 4, 5, 6, 7, 8. I end up on 0. How about -8, 0? That's a distance of 8 units, but is one number positive and the other negative? Hopefully you're thinking, no. 0 is neither positive nor negative, so that also does not work as a choice. Okay, let's try one more. I'll use yellow this time. This time I'm going to start at -4. I can pick any number to start at, so long as when I count 8 units, I end up in the positive zone. So 1, 2, 3, 4, 5, 6, 7, 8. I end up at +4. So from -4 to +4 is also 8 units. Maybe I'll make that a little darker. That might be hard to see in yellow on your Chromebook screens. Okay, the next question says that the distance between a positive and negative number, so again we want one that's positive, one that's negative, is 12.5 units. What could the numbers be? Well, now we have, a dreaded fraction in here. We have to go 12.5 units. So say I start at -8. I'm going to go 12.5 units. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then I need to go another half of a unit. So I'm going to go halfway in between 4 and 5. Now since that number's halfway between 4 and 5, that would be 4.5. So one possibility is -8 and 4.5. Let's try another possibility. This time I think I'm going to start at a half. I'm going to start here. Think about what that number would be. That's in between -5 and -4. Would that number be -4.5 or would it be -5.5? Hopefully you're thinking that that's -4.5 because as we go to the left, our numbers get more negative, so -4.5. And now I'm going to count up 12.5 units. So each time I count up, I have to go to the halfway point. That's 1. The next halfway point is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and if I go another half, that will get me all the way to 8. So -4.5 and 8. Well, this is kind of interesting. Over here we had -8 and 4.5, and now we have -4.5 and 8. So that's because the absolute value of -8 is 8. So if we're adding 8 plus 4.5, we get 12.5. The absolute value of -4.5 is 4.5. If we add 4.5 and 8, we get 12.5. Okay, let's try a couple more. Let's start at -3 this time. And let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and a half. That's in between 9 and 10, so that's 9.5. So -3, the distance between -3 and 9.5 is 12.5 units. This time I'm going to go backwards. I am going to start I'm going to start at 7. And I'm going to go backwards because it doesn't matter which way I go. I'm just looking for the distance in between. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and a half. This number's in between -5 and -6, so it's -5 and a half. So the distance between -5 and a half and 7 is 12 and a half units. Okay, now, what if we need to find the distance between two large numbers? How can we find distance without using the number line? Look back at the previous examples and try to come up with a rule for finding the distance between two numbers without using a number line. So this would be a good place to pause the video and look back at the other examples. See if you can come up with a rule on your own, and then you can unpause the video and check to see if you were right. Okay, so pause the video now. Okay, hopefully you took a second to think about this. Here's the rule. To find the distance between two numbers, between two numbers, subtract the numbers, and then take the absolute value. Okay, so if you need time to write this down, go ahead and pause the video so that you can see this and take some time to write it down. So to find the distance between two numbers, we're just going to subtract the numbers and then take the absolute value. What does that mean? Take the absolute value. Well, the absolute value of a number is its distance from 0. Absolute value is always positive. So when we subtract two numbers, if we get a negative answer, we're just going to make it positive. If we get a positive answer, we're going to leave it positive. So I'll show you how that works. We're going to go back to the examples that we did on the number line. If I can get the pages turned back. Here we go. Okay, so first we were finding the distance between -4 and 5. I'm going to subtract those two numbers. I'm going to do 5 minus -4. Now remember, when we are subtracting integers, remember our rule. Subtracting is the same as adding the opposite. I'm kind of losing my voice, but if you remember our song, subtracting is the same as adding the opposite, adding the opposite. Okay, so we're going to write this as adding the opposite. 5 plus the opposite of -4 is +4. 5 plus 4 is 9. So we subtracted the numbers, and the answer is positive. The absolute value of 9 is 9. So our answer is 9 units. Now, if I look at the next example, I'm going to do -4 minus 5. Now I'm going to rewrite this as adding the opposite. Whoops. -4 plus the opposite of +5 is -5. Same signs, add and keep. 4 plus 5 is 9. I keep the sign. Now, distance is always a positive number, so that's where the absolute value comes in. The absolute value of -9 is just 9. I'm going to write that over here. That looks like this. The absolute value, that's what those two lines mean, absolute value of -9 is 9. So either way I do it, the distance between those two numbers is 9 units. Okay, let's take a look at the next one. Okay, let's look at it here. So we're going to subtract the two numbers. First, let's do -3 minus -5. Let's rewrite that as adding the opposite. First number stays the same. We add. The opposite of -5 is +5. Now we have different signs, so we subtract and take the sign of the larger number. 5 minus 3 is 2. The number with the larger absolute value is +5, so our answer is +2, which goes with the distance that we have there. I don't know if you just heard that bark, but that was Sam. You guys know about Sam from Word Problems, and he and Major are playing right now, so you may hear some growling and barking. Okay, next one, -5 minus a -3. I'm going to rewrite this as adding the opposite. -5 plus the opposite of -3 is +3. Different signs, subtract, keep the sign of the larger number. So 5 minus 3 is 2. This time I'm going to keep the sign of -5, so my answer is -2. The absolute value of -2 is 2. So the distance between the two numbers is 2. Okay, same thing here. I'll do this a little more quickly. -1 minus 7. Subtracting is the same as adding the opposite. So we get -8. The absolute value of -8 is 8. So the distance is 8 units. 7 minus -1. I'm going to add the opposite, and I get 8. So once again, for both, I get 8. Okay, so just to review, to find the distance between two numbers, subtract, and then take the absolute value, or in other words, just make your answer positive. Just make your answer positive. So distance is always positive. Okay, let's take a look at what this looks like in a word problem. A hiker starts hiking at the beginning of a trail at a point which is 200 feet below sea level. He hikes to a location on the trail that is 580 feet above sea level and stops for lunch. Use the distance formula to find out how far he traveled. Okay, now remember, we're going to subtract the two numbers. So I'm going to start with the last number. So this number says it's 580 feet above sea level. So if it's above sea level, it's going to be positive 580. Now I'm going to subtract my other number. Well, my other number says that he started at a point which is 200 feet below sea level. Now remember, if it's below sea level, it's going to be negative. So I'm subtracting a negative 200. Okay, let's rewrite that as adding the opposite. 580 plus the opposite of negative 200 is positive 200. 580 plus 200 is 780. If you need to, you can write it out off to the side somewhere. And do your addition that way. So 780. So the distance that he traveled was 780 feet. Now show it on a number line. Number line is a good way to check to make sure that you did the problem correctly. So I'm going to say my hiker starts at this point. I'll put it here, negative 200. So let's put another dash there. That'll be negative 100. And then we'll go 100, 200, 300, 400, 500, 600. So 580 is going to be somewhere in between 500 and 600, but closer to the 600. So that'll be this line. This will be 580. Well, if we look at the distance from 580 to 0, that's 580 units, right? And then if we look at the distance from 0 to negative 200, that's 200 units. So to find this total distance from here to here, we have to add 580 plus 200, which is what we did to get 780 feet. So that makes sense. Our answer matches what we see on the number line. Okay, now, distance is always positive, as we just said. Now we're going to talk about change. Change can be positive or negative depending on the direction. This one says, after lunch, the hiker hiked back down the trail from the point of elevation, which is 580 feet above sea level. Let's just draw this as we go this time. So here's my number line. Here's 0. Here's our hiker. He's up here at 580 feet. And he's going to hike down the trail to the beginning, which was here somewhere, at negative 200 feet below sea level. This time it's asking us, what is the change in elevation? When we're finding the change, it's really important that we do the numbers in order, that we subtract in order. To find change, we start with the ending value and we subtract the starting value. So, where did the hiker end up? He ended up at the beginning of the trail, which is which is 200 feet below sea level. So yes, that's negative. I was just about to say it with a double negative. So the ending value is negative 200 minus the starting value. The starting value is where he started, which was 580 feet above sea level. So I have negative 200 minus 580. I'm going to rewrite that as adding the opposite. So I'm going to write negative 200 plus the opposite of positive 580 is negative 580. Now I have same signs, add and keep. 200 plus 580 is 780, and I'm going to keep the negative sign. So the change in elevation was negative 780 feet. The change does matter whether it's positive or negative. We went down, so his change was negative. The distance that the hiker traveled is just 780 feet. So it's the same number, but for change it was negative because we're going down, but distance is always positive. So the distance is 780 feet. Okay, this one says, find the change in temperature if the temperature rises from negative 18 degrees to 15 degrees. First use a formula, then use a number line. Okay, so remember my formula for change is the end minus the start equals change. Well, the temperature started at negative 18, it ended at 15. So 15 is my end minus my start is negative 18 degrees. So 15 minus negative 18. I'm going to rewrite that as adding the opposite. 15 plus the opposite of negative 18 is positive 18. So 15 plus 18, if you need to write it off to the side somewhere, you could. So like this, 15 and 18. I can add 8 plus 5 is 13. And then 1, 2, 3 is 33. Perfectly okay to do that. Okay, so we got a positive answer. Let's see if that works. I'm going to draw a thermometer. And I'm going to put my 0 here. I'm going to say temperature rises from negative 18 degrees. So the temperature started here, down at negative 18 degrees. And it rose to 15 degrees. That's going to be up here somewhere. So the temperature went from here to here. The temperature went up, so we would expect the change to be positive. Now, the next question asks us, would your answer be different if the temperature dropped? from 15 degrees to negative 18 degrees? Well, if it dropped, it's going down, so the change would be negative. So instead of being 33, we would expect that the change would be negative 33. And if we use our formula, that's exactly what happened. So if it dropped from 15 to negative 18 is our end now. So we're going to start with negative 18. We're going to subtract the start, which is 15. Hang on, I'm going to pause. I need to go give my dogs a... Okay, now, as we were saying, if it dropped from 15 degrees to negative 18 degrees, negative 18 is our end. This is our end, minus 15 degrees, which is our start. Now, if I write this as adding the opposite, I still start with negative 18. I add the opposite of 15, which is negative 15. Same signs, add and keep, and I keep my sign. So it is a change of negative 33 because the temperature went down, and going down is negative. Okay, this one says, what is the change in elevation from 140 feet above sea level to 40 feet below sea level? I'm going to do the end minus the start to give me the change. So the end is 40 feet below sea level. Since it's below sea level, that's going to be negative. Minus the start is 140 feet above sea level. I'm going to rewrite that as adding the opposite, negative 40, plus the opposite of positive 140 is negative 140. Now I have same signs. I'm going to add and keep. 140 plus 40 is 180. And I'm going to keep the sign. So the change is negative 180 feet. I'm going to draw a vertical number line to represent this. I'll use some blue here. So here's the sea level. That's 0. We're starting 140 feet above sea level. So we're up here somewhere. And then we're going 40 feet below sea level. That's going to be maybe here. So we're going, the distance from 140 to 0 is 140. The distance from 0 to negative 40 is 40 units. We're adding those two distances together to give us the total distance. So the total distance is 180 units, but change has to be negative because we're going down. Whoops, I'm trying to turn the page. And I think it's not turning because this is the last page. Okay, so what I would like you to do now is you have a worksheet that you're going to do for tomorrow. On the worksheet, the front side is just all problems of practicing changing subtraction to adding the opposite and doing it. So you'll get some review from yesterday. On the back side, there are some word problems. For the word problems, I want you to draw a number line for each one so that you can check your answer, and then you're also going to write an equation. All right, thank you for watching.